Welcome back, students. So in today's video we will be learning about 8085 addressing modes and instruction set. So let's first learn about the addressing modes. The addressing mode is the method to specify the operand of an instruction. Okay. uh, the job of the microprocessor is to execute a set of instructions stored in the memory to perform a specific task or operations require the following: the operator or opcode which determines what will be done, and the operands which define the data to be used in the operation. So, in simple words, the various ways of accessing data is called addressing modes. To access data from any memory location, like this is the memory, and to access the data from here is called addressing modes. How we access the data from this memory and use it in our operations. Okay. So, an addressing mode specifies how to calculate the effective memory address of an operand using information held in register or constant. Okay, as I have told you that addressing mode is how do we access different types of addressing mode means there are several different types from which how we can access the data and use it in our operations. There are five different types of addressing mode. These are the five most important types of addressing mode. There are many other types also, okay, but these five are important. First is immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and index addressing mode. So let's look at them one by one. So first of all, immediate addressing mode. The name immediate addressing came from the fact that the constant data is stored in the memory immediately. Okay, so as you can see this example, this move a comma hash 030h. This 030h is data. It is not the address of any data, but it is data itself. Okay, so that's what it is saying. The immediate addressing mode came from the fact that the constant data to be stored in the memory immediately after the opcode. This is opcode and the data is stored immediately after that. This is not address, it is data. In immediate addressing mode, the data is provided in the instruction itself. This is the instruction we have to perform, and this is the data that is being provided in the instruction. Okay, the data is provided immediately after the opcode. Same, the hash in the operand indicates it is the data, not the address of the register. Okay, the work of this symbol hash is that it indicates that this is the data, not the address of any other register. The immediate addressing is fast as to data to be loaded is given in the instruction itself. This is considered as the fast addressing mode because the data is given in the instruction itself. Now, second one is register addressing modes. In register addressing modes, one of the 8 register R0 to R7 is specified as an operand in instruction. So, in register addressing mode, there has to be one of the register. It doesn't matter it is R0, R1, R2, R3, R4, R5, R6 or R7. According to our relief, we will take the register, okay, whichever we want. But there should be one register. It is important to select the appropriate bank with the help of PSW. PSW register. We will learn about PSW register later. Okay, not right now. Just for right now, just you have to remember is that in register addressing mode, there is one register present. Like in this example, move A comma R5. Okay, so it will move the value whatever present is in register R5 to accumulator A. And here 8-bit content of register R5. This we will learn, okay, in our upcoming videos, not right now. Now our third is direct addressing mode. So in direct addressing mode, in this mode, the address of data is specified as the operand in the instruction. You got it? Now, see, as you can see, this is the instruction which we have to perform, and this 47H is not the data here. It is the address of the data. Okay, it is the address of the data. So this is what I have written down here. In this mode, the address of the data is specified as the operand. Address of the data is given here. Using direct addressing mode, we can access any register on chip variable. Okay, remember this on chip variable. We can only access from the RAM, from the internal memory. If we are attaching any external memory in 8051, we cannot access the data from the information from that memory in addressing mode while using direct addressing mode. Okay, so here data of the RAM location 40 is moved to the accumulator. So whatever data is present in this, let's say this is our RAM, and this is pointing. This is the address of the data. Let's say it is here, and whatever information is present in it, it will be moved to this accumulator. Okay, so this is what direct addressing mode is doing. Now let's see register indirect addressing mode. In this mode, the source and destination address is given in the register. By using register in direct addressing mode, the internal or external address can be accessed. Like in direct addressing mode, we were not able to uh, access the external memory if you are adding any external memory, but in register indirect addressing mode we can access the internal memory as well as external memory. If we are attaching it within some external memory, we can access both of them, okay, from the internal and external both. So the R1, the R0 and R1 are used for 8-bit address. Okay, so register R0 and R1 are used for 8-bit register, and DPTR, which is data pointer, is used for 16-bit address. Data pointer is also the same, that points the data which is an external is present in an external memory. Okay, so some examples are move a at the rate r1 and move a at the rate dptr. So this at the rate only signifies that this is an register indirect addressing mode. So you can easily identify that which type of instruction it is, or which type of addressing mode it comes in. So it comes in a register indirect addressing mode. In the first instruction, it shows R1 register is used. Okay, as you can see in the first function instruction, there R1 register is used, and if the content of R1 register is 40H, let's assume the content of R1 register is 40H, which is a data address. Okay, then that instruction will take the data which is located in the location 40H. As I have told you, this is our memory, and whichever data is located in the address 40H, it will take that data and and store it in accumulator. And in the second one, the content of A1 is overwritten by the location pointed by DPTR. Okay, in the second one also, whichever data is present, or this is pointing to some data, that data will be stored in this accumulator. Now let's see our addressing mode. Fifth addressing mode. So the fifth addressing mode is indexed addressing mode. So with indexed addressing mode, the effective address of the operand is the sum of the base of register and it is also simple. You can identify the indexed addressing mode just by seeing this addition sign between accumulator and the PC is a program counter, and this DPTR is a data pointer. So it is simple to identify that it is addressing mode. So what it is doing, the base address can either be DPTR, the base address can be this, or program counter, while the offset register is always accumulator. Okay, so this is the offset address. Okay, this will always remain accumulator, and we can only use program counter and data pointer in this addressing mode. The source memory can be accessed from the program memory, and also the source memory, whichever is the source memory, can only accessed by the program memory. And the destination operand is always register, and wherever we are storing our data is always the accumulator A or the register A. Here C refers to the code byte. You can see C here. It represents the code byte. In index addressing modes, only jump and move instructions can be used. So in this type of addressing mode, we can only use move instruction or jump instruction. As you can see, we have used here move instruction, but we can also use jump instruction. Only those two types of instruction we can use in this mode. Okay. Now let's seek a quick revision and a quick difference between these 5 addressing modes: immediate, register, direct, register indirect, and indexed. See, if you look the examples, immediate has hash in between, register is simple, register addressing mode have one register, direct have the data address, move also have one register, register indirect have a register but with an at the rate sign, and index had a addition symbol. So you can easily identify between these 5 types of addressing modes. Okay, as you look at this example, you can easily identify which is which addressing mode. So that's it for today's video. We will learn about instruction set in our upcoming video. Thank you.